Okay, here we go with the homeworks for 1920. Homework sheet number 1. First wee question just to get us off and running. Nice wee simple brackets 1. So, first thing to do is to write the 2x minus 5 squared as 2x minus 5 times 2x minus 5. Do your normal, remove the brackets method, get an answer. 3 things, so many squares, so many x's, something. Second expression, same thing, so many x squared, so many x's and a number at the end. And this time what we've got to do is add them together. So do like a great big add sum and you'll get so many x's, so many x squared, so many x's and then a number at the end. Hopefully it should be a nice easy start. Second question, our vectors. First thing we're asked to find is how do you get from A to B? Well, remember from what we're doing in class, that's little b minus little a. So take vector b, which is negative 6, 0, 2, and then subtract from that vector a, which is 2, 4, 1. Okay, and that's your answer. And then for the second part of the question, the length of that vector, remember that's where we do our Pythagoras. And because we've got 1, 2, 3 answers in the question above, then it's the first answer squared, add the second answer squared, add the third answer squared. Non-calculator question, so this should come out to be a nice easy number which you can square root. Question 3, factorise, so it's going to go into a pair of brackets. Now the only way which you can get 3x squared at the front here is if one bracket has a 3x and the other bracket has an x. Okay, so if you use my method for doing it, that would set up a 3x and an x at the top of your table. Next thing we do is we look at this number 4 here and think, how can we generate a 4? Well, 1 times 4, 2 times 2, or 4 times 1. Next stage from there is to cross multiply. So what's 3 4s and 1 1s? Can that make the negative 1 in the middle? What about 3 2s and 2 1s? Can that make the negative 1? What about 3 1s and 4 1s? Can that make negative 1? So once you decide which one it is, one's going to be positive or negative, you need to decide which one it is, and then the numbers go in here and here. Question 4. Fractions. Now remember, BODMAS says we do the brackets first, so we're going to do 2/3, add 3/4, so get a denominator which is consistent to both, which will be 12, get the new top numbers, get your answer. Off in mathematics means times, so it's going to be 2/5 times whatever this fraction here is. Do a little bit of cancelling. Okay, now I'm going to tell you, if you've done it properly, the 2 will cancel with something here to get your final answer. Question 5, an equation. Remember, we do not do this part first of all, the 4 take away 2. The first thing we do with this question is leave the 4 as it is and then do negative 2 times 3x, negative 2 times 6 equals 4 times x and 4 times positive 2. Then we need to move the 4x from this side to get it off of this side, take off the 4x, and then all your other numbers which are here, the 4 will go across, this number here will go across, tidy it up and you get x equals. Okay, now I'm going to tell you it's a fractional answer, so leave your answer as a fraction. It does not come out to be a nice easy whole number, leave it as a fraction. Question 6, a percentage, a compound interest question. So it's increasing by 25%. So 100 plus 25 is 125%. Turn that into a decimal, and then use that decimal to the power 5 times whatever the starting height is, which is 67, and that'll give you your answer. Okay, so your decimal to the power 5 times 67 for your final answer. We're quite good at those. Question 7, take a sphere, remould it into a cube. Now the volume of the sphere is 4/3 pi r cubed. Because it's the same shape and you're not going to lose any of the modelling clay, then the volume of the sphere is going to equal the volume of the cube. Now remember, the volume of a cube is L times L times L. Okay, what information do we know? Well, the question tells us that the radius of the sphere, the radius here, is 4 centimetres. So I can put that number into this formula, and that's got to equal L cubed. I'm going to swap it round about so it looks better for us. So L cubed equals, now I'm going to do this calculation on my calculator. That's going to give me a number. What's the length of the cube then? Well, how do we go from something cubed to the something? If it was a 2, if it was squared, we would square root. So because it's a cube, then that means we're going to cube root whatever this answer is in here, and then round it off. Question 8. Now, I'm going to really simplify question 8 so it makes it a wee bit easier for you. So rather than using the huge numbers that are there, let's make it a simple question. So the Earth has got a surface area of 4 kilometres squared, and Jupiter has a surface area of 20 kilometres squared. So I just made these numbers up. Okay, doesn't matter. I mean, the ones in the question are much bigger than that, but they'll do it with this. So the question is, how many times bigger is this number than that number? Okay, now because I've simplified the numbers so much, then hopefully everybody would tell me for this particular question that it's going to be 5 times bigger. You probably just did that in your head. However, the sum that you must have done was 20, the size of Jupiter, divided by 4, the size of Earth, to get the 5. Okay, so where I've used 4 and 20, you use the huge numbers which are in the question. Remember, on your calculator, you're going to either use the EXP button or the times 10 to the power X button. Some calculators have a button that says EE, but you're going to find that on your calculator someplace. Last question, number 9. Okay, here's your aeroplane. Let me draw the aeroplane for you. Right, here it is. It's flying over that dot. So it goes along here, ends up at this point. 1 minute later, and the question is, what's its speed? So speed is equal to distance divided by time. We know from the question that the time is 1 minute. Okay, what we don't know is the distance that it's actually flown. We don't know that distance there. Right, how much it's flown. What we do know is it's at a height of 10,000 metres. We do know that the angle of, let me fix that. We do know that the angle of depression is 38 degrees. So we know that this angle in here is 38. So if we do a right angle triangle, let me show this on the next page. So if we go back to the actual question, put your answer in here. Now the question asks for the answer in kilometres per hour. So this number here on the top, remember, is in metres. So how are you going to change that? You're going to have to divide it by 1,000 to put kilometres into metres into kilometres. The bottom is in minutes. So how many minutes is in an hour? 60. So once you get your whole answer, once you've done that calculation, right, divide it by 1,000 to put it into kilometres and times it by 60 to put it into hours. And there's your answer, kilometres per hour. It should be, let me tell you an answer, it is roughly 800 kilometres an hour. So that lets you know if you're on the right track. So if you get an answer round about 800, there's a fair chance that you're right. Okay, that should help, I hope. Here's your right angle triangle. We know this is 10,000. This is the distance here that we're trying to find. And we know that angle's 38. Okay, so if we name the sides in SOHCAHTOA, so the big long one's the hypotenuse, the one that's across from the angle is the opposite, the one which is next to the angle is the adjacent. So we're going to use the sides O, because we know it's 10,000, and A, because we're trying to find D. So O and A would make it a tan question. So tan equals O over A. Tan what? Tan 38 equals the opposite side is 10,000 divided by the side that you're trying to find the distance. Okay, that should now allow you, let me move that so I can write some more, that should now allow you to work out what D is. Check back your workings to find out how to do that.